You can download the arts in the video for free, link in the description. Create a new scene with the sprite 2D as the core. Right click, hit rename it to waypoint marker. Set the texture to the art atlas that you can download for free, link in the description. Go to texture and set the filter to nearest as we are using pixel art. Go to animation and set the H frames to 5 so that the arrow is selected. Go to ordering and set the Z index to the maximum. You don't need to set the Z index to the max, just make sure that it appears in front of all other objects in the game. Then go to scene save as, and save it. Then add a script. Inside the script, we will establish 3 export variables. On-screen offset is the offset of the waypoint sprite when it is visible on the screen. This will ensure that the marker is positioned correctly above the character's head. Screen margin is the distance from the edges of the screen that the waypoint marker will be while the character it is attached to is off-screen. And smoothing speed is the speed of the marker's rotation and movement. Then we will add a variable to store the active camera node. So inside the built-in ready function, we will set the camera node to the viewport's active camera 2D. The viewport is above the scene's core and is what's displayed to the screen when you are playing. This will simply grab whatever camera 2D node that is active within the scene. Inside the built-in process function, we will check if the camera node has not been set yet. Then we will try to set it again, then call return. Return will basically stop all code below it from running, ensuring that the code can only continue once the camera node is found. Then we will establish 6 variables. Target global position is the position of what the marker is pointing towards, which for us will be the parent's global position, as this marker will need to be added as a child to all the nodes that you want to mark. Viewport dimensions will simply grab the size of the screen. Screen coordinates will provide a vector 2. That is the position of the target if the 0, 0 of the target's position was the camera's top leftmost point. This will essentially allow us to check from the position of 0, 0 to the position of the size of the screen, which is from the top left corner to the bottom right, to know whether or not the target is within the screen or not. Target global position minus camera node.global position will grab the offset from the camera to the target. Then we multiply it by the camera zoom to take zoom into account. Then we make sure that the origin is at the top left of the camera because it simplifies our check of if the target is on position, as we can just take this variable, then check if the number it returns falls within 0 to the screen size. Green inset rectangle is a 2D rectangle that represents the area that we consider as on-screen. Using the screen coordinates variable, we can check if that falls within this rect2 to know if the target is on-screen or not. We use rect2, passing the minimum of a vector 2 of 0, 0, and the maximum of the viewport dimensions. We then use grow with a negative screen margin to shrink the rect2 so that the marker respects the margin. The margin is the amount of pixels away from the edges of the screen that we force the marker to be so that the marker isn't touching the screen's edge. Finally, we have 2 variables to state the target rotation and position. This is simply for our lerp later on, so we can smooth the position and rotation. Then we check if the rect2 has the point of screen coordinates, meaning that the target is on screen. Then we set the target display position to be that target's global position plus any offset that we have, and we set the rotation to 0. This is so the arrow is just pointing downwards above the target's head. Else, if the target is not on the screen, we create 3 variables for setting the position. Clamped X and clamped Y will take their respective screen coordinate value and make sure it falls within the size of the screen, while taking the margin into account. Clamp simply makes sure that the first value is more than the second, but less than the third. Then clamped screen coords puts these variables into a vector 2. We set target display position to the camera's global position plus clamped screen coordinates so that the position is on the edge of the screen, and we minus this by half of the viewport dimensions to change the origin of the clamped screen coordinates from 0, 0 to the center of the screen. Then we divide this by the camera's zoom to take zoom into account. For the rotation, we create a variable called vector to target, which provides the direction towards the target from the screen. Then we set the target display rotation to an angle conversion of the vector to target with an offset of half of pi. This will just offset by 90 degrees clockwise. Finally, we lerp the global position and rotation to their respective target. A lerp will simply move the first value towards the second at a rate or speed of the third, which is known as the weight. We make sure to multiply smoothing speed by delta to ensure that the lerp is frame rate independent. Now to add this marker into your game, simply go to the scene that you want the waypoint to point towards. Then add the waypoint marker as a child. From here, you can then set any of the exported variables on the right and customize the marker so it fits each individual character. Additionally, you can change the color of the marker through modulate, so each character's marker is unique from one another. Now you have an on-screen waypoint marker that points towards a target and rests above their head when the target is on screen, while taking the camera zoom into consideration. And don't forget that you can check out the project files, link in the description.